Hello, I'm Lars Strong, Senior Engineer with Upsite Technologies, and I'd like to share some information with you about infrared thermometers, how to use them, some various types, some things to look for, and help you understand one of the most useful tools and a very inexpensive tool for monitoring and managing the cooling in a computer room. So there's several different types. They range anywhere from a very cheap one that you can get for just a few tens of dollars, all the way up to several $100s for an infrared thermometer. And now I want to make the distinction between an infrared thermometer and an infrared camera. I'll be focusing today just on infrared thermometers, not on cameras. Although the line between the two is getting a little fuzzy, as I'll show you with a couple of versions that are available today. So another type of infrared thermometer that's available is one that has a K-type thermocouple port or receptacle, so that you can plug in a K-type thermocouple, and that can be a real useful combination tool. So it's both an infrared thermometer, and then when you plug in the K-type thermocouple, you can use that lead and put that lead, say, down into an opening in a supply tile to measure the air temperature real closely as it's passing underneath the tile or coming out of the tile. You can pass that thermocouple, that thin wire with the thermocouple at the end, through an opening in a cabinet, perforation in a cabinet, to get an inlet temperature reading of a server accurately, or to measure the exhaust temperature from servers. So these thermocouples are a very useful feature in some infrared thermometers. So they're often referred to as a temp gun. The full technical name is a non-contact infrared thermometer, and they are used to measure the infrared energy that is emitted from solid objects. So our goal is to monitor, quite often in use in a computer room, we're trying to use them to determine air temperature. Well, an infrared thermometer or an infrared camera is incapable of measuring air temperature. But we can measure the surface temperature of the materials that the air is flowing over. And that'll give us a very good indication of what the air temperature is flowing over those objects. So it's a useful way to identify temperature variations in the computer room and where adjustments need to be made. So let's talk about a few types. So again, we can start with a very simple one such as this. This is one I like to use. Real simple, fits in your pocket. Just has a display and a single laser indicator of where it's doing the measurement. And then you can go to something more sophisticated and more complicated like this. This is a FLIR model. And this, in addition to being an infrared thermometer, also has a visible display of an infrared camera as well. Now, it is not using the infrared camera information to give you the temperature. It is still operating exactly as a simple infrared thermometer to give you the temperature of a spot size. Let's talk about the spot size and the way that these tools measure temperature. So you can see that on the inlet, on the front side of the infrared thermometer, there's an opening. So if you hold this right against a surface, it'll still work. It doesn't need any space or any air. It will measure the temperature of a circle that is that size of the opening. And the further away that you get from an object, the larger that spot size is that the infrared thermometer is measuring. And so the way you understand what that spot size is by the distance to spot ratio. And so each infrared thermometer will have its own distance to spot ratio. So if you're measuring an object that is say 10 feet away, and it has a 10-to-1 spot ratio, if it's 10 feet away, it'll have a 1 foot spot that it is averaging the temperature of. So this is something you need to consider when measuring objects at a distance. If you're measuring something that's far away and you're measuring a large spot size. If half of that spot size is hot and half of the spot size is cool or cooler, then you're going to get the average temperature of all the objects in that spot size. So it's important to make sure that the spot size matches the object you're trying to measure the temperature of. Another consideration with infrared thermometers is a term called emissivity. Emissivity is essentially the willingness of a material to reveal its temperature. Is it emitting energy, infrared energy, that is easily seen or that is associated with the temperature of the object? So you can have a hot piece of chrome and a hot, say, glass of water. They're the same temperature, but the glass of water will appear warmer from infrared energy perspective because the emissivity of glass and water is very high, so it's revealing its temperature. Whereas if you're measuring shiny materials, the most extreme example is shiny chrome, it doesn't reveal its energy very clearly. So some of the more expensive infrared thermometers have adjustable emissivity, and the less expensive ones don't. They're generally set at the higher range that is equivalent, that is appropriate for measuring objects such as glass or rough rubber or painted surfaces. So these things reveal their energy fairly clearly. And you can see in this chart that there's different emissivity for these different objects. And just something to be aware of as you're looking at temperatures in the computer room. Now, one of the tricks that you can use regarding emissivity is that masking tape has a high emissivity. It's going to reveal its temperature and give you an accurate reading. So one of the things that I do if I'm doing a study and I'm wanting to measure the temperatures in an aisle of equipment as I change tiles or make changes to set points, fan speeds and those things, is I will put pieces of masking tape along the cabinets, maybe a row across the top, middle, and at the bottom. And that does two things. It gives me an accurate reading of what the temperature is at that location, and it also gives me a consistent spot to measure the temperature, so I'm more likely to see the changes that occur. This is also really useful if measuring the temperature of pipes. Pipes are a curved surface. They can be fairly reflective. So if you put a piece of masking tape on a pipe, then you can hold the infrared thermometer very close to that tape and get the real temperature of that pipe. It takes a little bit of time for changes to be reflected in the tape, but that's one of the good things, is that the tape doesn't have a lot of mass, and so it's fairly quick to reflect the changes in temperature of the environment around it. So let's take a look now at how to use the infrared thermometer to measure inlet temperatures in a server cabinet. One of the most likely things that you'll be using it for. The most useful way to measure inlet temperatures in a cabinet is to pull and hold the trigger of the infrared thermometer and then pan back and forth across the inlets of the equipment. The temperature of blanking panels is not particularly relevant because it's possible for a blanking panel to be hot as it's holding the hot air in the cabinet, and that not to be an indication of the inlet temperature to the IT equipment. What you're really interested in is the temperatures that you read as you are passing over the inlets. And if you come across a high inlet temperature, you can stop and investigate a little more closely. Even if you have extensive monitoring in place, say you have a permanently located temperature sensor at the top, middle, and bottom of every third cabinet in an aisle, or even if you have it in every cabinet in an aisle, there's still a lot of area within that cabinet that you don't have a temperature sensor. So an infrared thermometer or an infrared camera can give you a very quick understanding of what the temperatures are like in that aisle. So if you pull the trigger and let go, then you will get a reading on the display that shows what that temperature was when you pulled the trigger. However, you don't need to click and release. I've seen people going through and just shooting over and over. You can pull on the trigger, hold it steady, and now just pass the infrared, wave the infrared thermometer back and forth across the front of the IT intakes and watch the display, and in just a few seconds or less, you can scan an entire cabinet and get a good sense of what the inlet temperatures are within that cabinet. It's important to consider a few things when measuring inlet temperatures in a cabinet. One is that it's possible to get reflected energy off of the surface of the inlets of the IT equipment, depending on the type of material and the type of surface of that inlet. These are nice, flat, and black plastic and will give a fairly accurate reading. However, if they were polished or smooth, then it's possible to have reflected energy off of the ceiling or some other high temperature locations, such as a light, have that infrared energy reflect off of the surface and give you an inaccurately high reading. So consider the reflectivity of the material that you're measuring. Another possibility for getting an inaccurately high reading is that it's possible to be looking down into the belly of the beast, as it were. You can be looking and pointing the infrared thermometer down into the server, and there can be hot components inside the server, and that hot energy is shining out towards the thermometer, even though the cool air or the conditioned air is going into the server. So one of the ways to avoid that is if you get a particularly high intake temperature, you can tilt the infrared thermometer to the side so that you're getting better readings on the temperature of the louvers and not looking down into the throat of the server and potentially getting high inlet temperatures from hot components within the equipment. So really the technique is to just hold the trigger and quickly pass back and forth over the entire cabinet, and it only takes a second or two to measure the temperatures across the entire cabinet. If you come across a high temperature in a location, you can slow down, investigate, make some adjustments to see if the temperature goes away, drops to a lower temperature, or if that's truly the intake temperature of the air to the server. As in this case, we might be getting very high inlet temperatures or higher inlet temperatures for this piece of equipment because there's a missing blanking panel right above it. Now, as you're watching that display, you can quickly see how the inlet temperature, how the temperature is changing. So you can see that it reacts very quickly. As I pass this infrared thermometer across my hand, you see the temperature goes up and down very quickly. And so as you're passing it across the server inlets, if you see a high inlet temperature occur, you can slow down and investigate more closely. All right, well, thank you for your time. I hope you found this information useful, and if you have any questions about anything that I've shared or how to apply this in your facility, please get in touch with us and be happy to have a conversation with you. Thank you very much.